Dead men tell no tales, but their ships speak volumes. Welcome to the Cursed Compass, where we explore the darkest maritime mysteries. In late August 2018, local authorities discovered an uncrewed cargo vessel grounded on a sandbank in the Gulf of Martaban, drifting entirely without power or personnel. 2 decades before its discovery in Myanmar, this vessel was designated Hull 156. Constructed at the Paul Indonesia Parawakan Yard in Surabaya, the ship required nearly 3 years of structural assembly before its final delivery in January 2001. This hull measures 177.4 meters in length and was engineered to support 26,510 deadweight tons of cargo, fuel, and stores, with a total internal volume rating of 18,247 gross tonnage. To understand how a machine of this scale became a total loss, we must forensically analyze its architecture, tracing its design from the engine room to the deck stowage geometry. The Sam Ratulangi was designed as a standardized, modular steel system, built specifically for the logistical demands of regional feeder routes, moving cargo between local ports and major maritime hubs. Studying the structural limits of this feeder class reveals how physical forces and economic margins dictate the design of the workhorses that sustain regional supply chains. We begin at the mechanical core of the vessel, located deep within the aft section, the main engine room. This model isolates the power plant, an MAN B&W 7L60MC, a 7-cylinder, low-speed marine diesel engine. At full combustion, it generates 13,440 kilowatts, roughly 18,273 metric horsepower. This power transfers through a longitudinal drive shaft to a fixed-pitch propeller, providing thrust for the 26,000-ton hull. This mechanical configuration propels the vessel to a maximum service speed of 19 knots, or approximately 35 kilometers per hour. The economic viability of a regional container ship relies on this calibration. The engine must generate enough thrust for schedule reliability, while staying within the narrow fuel consumption limits that define a profitable voyage. Above the engine room, the main deck reveals an architectural layout designed entirely for cargo throughput. Looking at the top-down arrangement, the deck house containing the bridge and crew quarters is positioned far aft. This placement maximizes the continuous load space for the 10 distinct container bays stretching toward the bow. Longitudinally, each bay is sized for 20 20-foot containers, or 10 40-foot containers end-to-end. Across the ship's width, the beam allows 11 containers to be stacked side by side. Naval architecture treats the modern ship as a floating, highly constrained mathematical grid, where every dimension is dictated by the 20-foot equivalent unit, or TEU. That grid extends below the deck, dividing the cargo between exposed upper layers and internal holds. Heavy pontoon hatch covers seal the lower internal holds from the elements, while also acting as the structural foundation for the containers stacked above them. Utilizing all available slots across the deck and lower holds, the ship's total carrying capacity is exactly 1,644 TEU. However, the single container bay positioned immediately forward of the deckhouse follows different loading rules. Here, containers are only loaded above deck, because the volume directly beneath is entirely occupied by the engine room. To maintain versatility in smaller, less equipped ports, the hull was structurally prepared for the installation of onboard cranes, allowing for autonomous loading. These internal mechanical requirements, specifically the engine's placement, permanently set the limits for the ship's commercial payload. By 2018, the Sam Ratulangi had reached the end of its economic lifespan and was sold for scrap. Reaching the scrapyard required a dead ship tow, a high-risk operation where a vessel is moved across open water with zero internal propulsion or steering. In August 2018, a tugboat attempted to pull the unpowered hull from Jakarta toward the dismantling facilities in Chittagong, Bangladesh. The tugboat provides forward force, while the 18,000-ton hull creates massive resistance, channeling all tension into the towline. On August 13th, heavy sea states pushed the hull off-axis. The dynamic loads instantly exceeded the line's maximum tensile limits, causing the connection to snap. Weather conditions prevented the tug crew from re-establishing the connection, leaving the hull to drift uncontrolled. Without its own propulsion, the ship became a hydrodynamic liability, entirely subject to the physical variables of wind and current. The abandoned hull drifted into the currents of the Gulf of Martaban for over 2 weeks. In late August, the Sam Ratulangi finally grounded on a sandbank near the mouth of the Sittaung River. Salvage operators attempted to restore buoyancy to the vessel, but the dead weight of the hull and the suction of the silt made refloating impossible. By October 2018, the hull's structural integrity failed under the constant stress of the tide, and the vessel partially sank into the sandbank. This photograph shows the intended destination, the shipbreaking yards of Chittagong. Here, hulls are driven onto the beach to be systematically dismantled. In these yards, heavy machinery and manual labor reduce a vessel to its component materials, allowing the steel to be recycled into new industrial projects. The architecture of the Sam Ratulangi defined its operational life, but the loss of its propulsion systems left the vessel entirely subject to the physical variables of current and tide.